Hey boys and girls, we have some big surprises for you today. I'm at Corning, and today we're going to look at how we bend glass, among other things. And we're going to have quite a few folks here, and I'm not even going to try and introduce them. They're going to introduce themselves. Kick it off.
So I'm Mike Kunigonis. I'm the general manager of Corning's Automotive Glass Solutions business.
Brad Bowden, I'm the technology director for the Automotive Glass Solutions business.
Khaled Leivni, I'm technology director, new product development and reliability.
I'm Achim Heibel, responsible for the shape project at Automotive Glass Solutions.
And I'm Fabio Salgado. I'm the commercial director for Automotive Glass Solutions.
So what we've got here is the brain trust at Corning, and so far they've already given me pretty much enough of a tour to know that I don't know anything about glass. So here's the deal. We're going to have a very, very interesting video this time showing you all of the attributes and all the magic that's associated with the Corning Glass Company. So let's get started.
Basically, we are working with all the OEMs in the industry and the supply chain, and we see that shape is a very important factor coming forward for displays. And we found a pretty lean solution by basically using flat glass and processing it all in flat and then allowing it to be put in shape just before you put the module together. And that's what Khaled will talk about here more in detail and give you a couple of examples and show you the details of the process and the great attributes we have put in our glass to enable that. Okay?
So, as you may have noticed the past few years, the interior of the car is becoming more design driven. So OEMs are willing to create the same experience we have with our smartphones, but inside the car. So you see more shapes, larger, and also more exposed display inside the car, instead of the little displays we used to have in the past few years. So when we looked at this new use case, we observed the designs and we work very closely with OEMs. So we try to anticipate their needs and also bring in the right solution. So if you look at the designs that we have today, you can see this kind of shapes, what we call C shapes, or we have other. So the geometry are not too complicated.
Yeah.
So when you think about formed glass, the immediate thought is we should hot form it, which means we take a flat piece of glass like this one and go through an oven, heat it up to a couple hundreds of degrees to obtain this shape. So the problem by doing this is that you start from almost pristine piece of glass and you heat it up. When you heat it up, by definition, you will modify the surface. You will create some defects, whatever the process you'll go through. And also, this is costly and it's not energy efficient, because you have to heat up the glass. Now, when we have looked at these designs, we said, if we create a strong enough glass, we may bend it and it can stay during the lifetime in this situation. The advantage of this, we don't need to heat up the glass.
Yeah.
We can use all the benefits of making the glass in flat state. So in this application, as you can see, you have seen decoration. So that's an example of finished part. So you start with the fusion draw process. So pristine glass surface. Then we cut it. We finish the edge. Then we do the decoration. That's the black mask that is masking all that we don't want to see. And then there is decoration on the A side. So this is the B side, so that's the side that you don't touch. And on the A side, you have decoration, you have other functions.
Right.
So we do all this in 2D, so flat. So you take the benefit of the quality of the 2D, and you can, then this piece can be sent to the display maker. And then the display maker, they can still continue working with a display glass. So they can use their existing assets for flat glass, and they can laminate the display behind the glass. And once they do this, so the glass is so strong, so they can bend it like this. And you will use this part. So that's the mass production part that is inside the car. So you have, this is the instrument cluster,
Yeah.
and you have the central console. So the advantage of doing this is that you can have superior quality of hot formed part with the 2D economics.
So what I'm bending here under this plastic is glass.
Yeah.
This is glass.
Yes.
How much deformation can you get?
Oh, so we can go very tight. It depends on the thickness.
How thick is
But-
this?
So this
Feels
one
like
is
a millimeter.
1.1 millimeter.
Yeah.
Yes. For 1.1 millimeter, we can go down to 200 millimeter bending radius.
So maybe you show it.
Yes. So you can go very. So this one is very.
Yeah,
so
I wanted to do
this
that.
is
but
large.
yeah.
Yeah. But
don't
we
wanna-
can go much tighter.
Yeah.
200 millimeter for 1.1. For 0.7, we can go down to 150, and it's thickness related. So we can go really very tight.
Yeah, go. It's good.
Go. Are you
Yeah.
kidding?
That's good.
Good.
Are you kidding? Oh, you
Take a
gotta
picture of
see this.
Yeah.
I'm waiting for an explosion.
No. That's good.
You're good.
Good.
So basically, I've made a U out of a piece of 1.1 millimeter glass. Okay, that's magic.
So we're going to show you an example of the process. It's a lab scale, obviously, but this shows the main principle of how we do the cold forming. Typically, we use a vacuum check. Joe, you can start. So the way we bend the glass is very simple. Just turn the vacuum on, done. The forming is done. So if you think about how we do the forming compared to heating the glass, that's a very lean process. So, and the advantage of doing this is the shape of the glass is exactly the shape of the CAD file we have. That's what the customer sent us. That's perfect shape. The only deviation will come from the frame. So Joe is approaching the frame. He has double-sided adhesive here around. That's example, you can use another kind of adhesive. And then he will approaching the frame and contacting the double-sided to the glass. Obviously, you can do some alignment, engineering stuff, and actually the process is done. The part is ready. So that's ColdForm part. So radius is about 2,000. That's in the average of the shape you see in the market and the mass production that Akim was leading to. We see even wider bending radius. So 2,000 is not a big deal. It's really, and we have many European car and mass production using this radius.
It's
Different
very,
shapes. Also, we also using convex. This is concave. You see an example.
Obviously, yes.
Yeah.
So we always talk about building blocks.
Yeah.
So C-shape, concave, convex, and then you can imagine, for example, Z-shape or W-shape or T-shape. We have the recipe for the building blocks, and then we can extend to a variety of designs inside the car. So the other advantage, I think I mentioned very briefly, but when we talk about tolerances and engineering, in this specific case, if you use, let's say, this part with the frame, you have the tolerance of this part. And you have the tolerance of the frame, and the glue thickness should deal with both tolerances. In our case, there is almost no tolerance from the glass because the glass is shaped mechanically at room temperature to our perfect shape. So the only tolerance we have to deal with is the frame. And this becomes important when we deal with these pillar-to-pillar parts, because the longer you have, the tolerance will go up.
Yeah.
And if you are willing to keep a cost-effective part, that's really a key player in this technology. So you divide your problem by 2.
So excellent. This is really quite amazing, actually. I'm I guess I must have seen it, but I always felt that it was probably just, you know, heated and bent, and that was same thing I would do for like a windshield or something. So can this be turned into a windshield, or is this just strictly for optical display and things like that?
Can it, sorry?
For a windshield.
Oh,
Could
yes,
this
yeah,
be-
yeah, absolutely. Yes.
Because if it can take the impact, I mean, it would seem to me that
Yes. So the main design guideline for doing ColdForming is we do it with mainly one-axis bending, one direction. We can do some two-axis bending with some limitation. So what we can do with a piece of paper, you can do it with a glass. So you can take a piece of paper and apply one radius in one direction, another larger radius in another direction. If you can do it with a paper, with a given thickness, you can do it with a glass. So that's the only limitation we have. If you have the right glass, obviously. For this application, we discussed previously about materials, plastic, metals, etc.
Right.
So one question is why we need glass for this application. So one thing is plastics, polymeric material, they are very sensitive to sun, UV.
Yes, they are.
So that's a test that mimics lifetime of a car. That was protected, that was not protected. So yellowing is a big issue. So durability of the plastic is a really big issue. So that's one thing. You can find maybe advanced grades of plastic, but you still have yellowing. Maybe less, but you still have yellowing. So that's the first problem. Second problem is you will touch the screen. You want to interact the screen as you interact with your smartphone. So, but the plastic is not durable. So we have three materials here: plastic, a glass, standard glass, and Gorilla Glass. So that's a key. So if you can just try to scratch and see the difference, you may notice. Okay, harder.
Yikes. Well, I can't. It skips. I can't make anything happen there. This one here is folding away, and I scratched them both.
Yeah. So plastic scratches. So you can improve, but you still see scratches. That's polymeric material. You will have locally damage happening, etc. It's creasing. Glass. You know, glass could be the solution if you use the right glass. If you don't use the right glass, you almost have the same result. And for Gorilla, as you can see, you cannot create scratch.
Yeah, it basically left a white mark, which I rubbed out with my finger. So that's maybe the key, that So
trace of the metal.
Yeah.
So that's why. Plastic is not the ideal material. Glass, much better, but you need to pick up the right glass. So I mentioned Gorilla Glass. Another use case is, I think you asked the question about impact or durability. So this is scratch, we are sliding object. We can also think about pushing or impacting locally. So we have three kinds of glass. This is soda lime glass, very similar to what you find used in Windows. So what I suggest is that you use this tool and just try to push, like
Just push.
local force, in the circle. Okay. So that's broken.
That didn't work. Yeah.
Okay. So that's broke. So now one thing that people use as entry-level material is to ion exchange or strengthen soda lime glass.
Yeah.
So that's the one. It's strengthened. So it's a little bit harder because you have some compression and strengthening happening, but you will end up with the same similar failure mode. Now what you can try now is Gorilla Glass, and you can do the same thing and see what you can see.
Nope, that didn't do anything. It put a dimple in the plastic
In the plastic,
shield.
yes.
Yeah.
And the plastic is just for
I have a
packaging.
lot of doubting Thomases that watch my thing. Let me just try this again
Yeah, you can try.
with everything. Nope.
Yeah.
I'll poke a hole in my hand before. Look at that. I've been call a medic.
So that's what all about Gorilla Glass. So now for this application, I mentioned the auto-grade Gorilla Glass for cold forming, to enable cold forming and the strength of the glass. Now we are inside the car. Even if the part is not formed, it's flat. One use case that is important is headform impact. There are standards, European, US, and others. They are almost the same. There are two criteria. First one, when you hit, you should not exceed ATG, deceleration, for more than 3 milliseconds in order to avoid damaging the brain. That's one thing. So that's more system level related. And the second one is safe behavior. So most of the OEM do not want the glass to break. And what this says is, so this is mimicking the head. So this is 15-pound head. And you hit with this head the display in several places. And this should, the glass should not break. Okay. So that's one example, mass production part. Okay. That obviously we hit many times.
With this?
Yeah, with this one. And what you can see, so you can touch the cover glass, auto-grade Gorilla Glass, did not break. What you see is the display behind that is breaking. And so that's a glass, but even more, if you turn it, you can see a lot of damage because we hit it many times. So, so this is metal. So metal is breaking, deforming.
Is that aluminum or magnesium?
So this is aluminum. This is aluminum and this is steel. So that's quite stiff. So that's the head that we have seen previously. That's the 15-pound head. I think you can go. Okay. So the glass survived. So typically, in order to invent this glass, we have really to understand a few things. What are the stresses that are applied to the glass? Because it's system, but the glass has a big role. So we have defined the range of the stresses that the glass can see. Also, what's the strength of the glass and what composition we have to put in place in order to resist to this stress. By playing with composition, by playing with composition and of the glass, we came up with this auto-grade glass that survives the headform impact test. So that's the part that you have.
Pretty much amazing, I think. Yeah.
And obviously, what we are showing you here, this is a flat part. We can do it on curved parts. So, and by the way, we have invented two glasses, one that is for flat application, and for curved application, it's even stronger. So we can compensate any bending stress that is coming from curving the glass. So now we are hitting, let's say, a non-adequate glass for this application with the same conditions, same setup. You can go.
Didn't hold up nearly as well.
Yeah. So you see all these marks. This is representing the energy that is applied to the glass. So the tighter is the spider web. That means that you have higher energy. So all this energy, when it's applied to this glass, if you don't have the right glass, obviously that's what will happen in real application. So when you don't use the right glass in the car, in order to enable homologation of the car, you have to put a film, plastic film on top of it. So you lose all the benefit of having the glass, the scratch that you, and that's not a good news for the OEM.
Yeah.
So that's something we help avoiding by using auto-grade glass.
Yeah, so this is our lighthouse. This is where we are able to look at some of our products in a pretty bright illumination. So I don't know what this will do to your camera, but we can really turn up the light in here. You can see that this light is kind of red. This is not really like daylight, right? And so for most of our devices, they're going to be out in the car. So what we really care about is daylight. If you look above you, you'll see that those lights are a little bluer.
Yeah.
It's kind of dim right now. I'm going to walk over here. But if we turn this up, we can get a pretty bright illumination in here. So we use this to really look at some of our products under the illumination that they're meant to be looked at. These are 3 different displays that we have. This lower one, you can see, has anti-glare on it. So it has a nice touch on it. But it's pretty reflective, as you can see, right? It looks kind of white when you look at it. The middle one has both anti-glare and anti-reflection. So they're two different coatings. They have like the matte finish on the middle one, and then an anti-reflection coating. And the top one is anti-reflection only. And so we really use this demo to kind of compare and contrast the different types of displays that we have.
Is this the same screen that I saw downstairs?
Yeah, this is also ColdFormed.
Yeah.
Upstairs, right? I guess.
Yeah. Or the other building. Yeah.
Yeah, so this one shows
This is
ColdForm.
brilliant. This is, I could put this in a convertible. That's one of the big reasons you've still got steam gauges in some open top cars. Actually, some cars in general you just can't make it bright enough. That looks plenty bright.
A little harder to see in this room because it's dark. It looks like it's doing well, but what would it look like in the sunlight? But this one actually has the technology that enhances that ambient contrast ratio. So when we had it at CES, we were in a much brighter room with the overhead lighting, and it looked great. So people really like this. So if I turn this off, you can see
That's
this
the
sort of
black,
seamless.
yeah.
You can't see the boundaries between all the displays.
Do that again? No, with...
What's that?
Oh, I thought it was your watch. Yeah, but actually it's...
So this will boot
Proximity.
it up again.
Yeah.
This is booting it up. But you can see it. It looks seamless, right? You can't see the divisions between the different displays on here, or the boundaries.
There's three very different display technology, and what our objective is that the end user basically doesn't recognize it, that it appears seamless to them.
Yeah.
And that's what we do with this technology, kind of blend it in.
And one of the issues we have is like LCD panels versus OLED panels from different manufacturers. They'll look different in reflectivity.
Yeah.
And some of them are pretty dramatically, they'll look orange. So when you get in a vehicle and you look, some of the new ones you'll see out there right now have this. The display looks orange in reflection. Nobody wants an orange display. So our technology kind of takes that and makes it more seamless and also enhances this ambient contrast for readability.
Well, like I said, when you turned this off, there's nothing wrong with that.
So one of our goals is to try to make, even with those low reflectivities, a very seamless look. And so we work a lot with different tier ones and display makers to get this sort of seamless look. Yep. And one way we have of doing that is rendering. So we do a lot of computer rendering. And the one thing that we do a little differently is that we try to put the real optical physics in the rendering without all of the tricks that you might use in a movie or something like that, right? So in our optical rendering, and I can show you some of these. So here's one on, I'm having a little trouble with the screen today. So this is a rendering we do, so a similar display to what you're seeing, and you can see the color matching. We kind of enhance that and that as well. And here we can see, this is a typical situation we get where the display is more reflective than our black inks.
Yeah.
And everybody wants us to somehow dim the display. We can't really do that. So we take them through our different ink options and say, hey, this would be the best ink. This is the ink we're going to give for your project, right? And so then we can go back to rendering and say, this is what your ink's going to look like, and here's the contrast we get. And if you chose another ink, you can see we're changing the color of the ink. You get a good match there, and now the ink is too bright.
Yeah.
So we can work with customers, and we've had really good interactions with this and saying, hey, this is the issue you're having right now. We can go to different anti-reflection coatings, right? The anti-reflection coatings, you'll notice, if you have them on different devices, often have a color to them. It's hard to make them completely neutral. And so that color gets added to what you see in the display. And so here's that orange display I'm talking about, right?
Oh, yeah.
That we see. You don't really like it. So what if you could do something on the anti-reflection coating to make that more neutral? And so you'll see in a minute that we'll split the screen here, and we have a coating technology that we use to change this from being orange to something much more neutral. So now you can see top and bottom, we get a much more neutral look to the display. So we work with a lot of our customers and display manufacturers to try to do this sort of combined technology and look at the total system performance to get it to be what you want as a designer.
And then when you manufacture it, it's perfect, exactly what the customer wants.
Well, it's closer
I'm
for
a
sure.
big fan
Yeah, there's
of,
always.
I prefer to, get the first right, best design on the computer,
Exactly.
and then, some polishing might be necessary
Yep.
when you get into reality, but usually not a heck of a lot. It's gotten less and less and less
Yeah.
over the years.
And before we did this, I'd say 9 out of 10 of our programs were, they changed from the first day we talked to the
Yeah.
customer to when it actually went into production. It was a different ink, a different anti-reflection
Right.
coating. This has reduced that a lot. So we're a lot faster. We're not having to make a
Yeah.
lot of prototypes and
Yeah.
redo things. And so our cost and the value to the customers has been pretty great with this.
Yeah.
And it's not trial and error, right? You're going
Yeah,
down to
yeah,
the scientific
right.
level to.
Yeah.
Here's an interesting one on readability. So if you watch this one, this is with a moving background, right? So this would be bare glass. It's pretty hard to read the speed. This is with anti-glare. You can see it's easier. This is with AR, but you're not blurring the background, so you're getting a lot of.
Yeah.
But this is the combined anti-reflection and anti-glare. Really easy to see this, right? And so the question is, what do you value? Do you value readability for your customer when they're out in the light? Or do you value some glossy, high-performance look? And different customers have different things they prioritize. And so we can deliver and kind of show them, hey, this is the value of one over the other. But if you don't like AG, hey, we'll do anti-glare or anti-reflection coating.
Yeah.
And we'll get good performance either way. But there's a lot of different opinions out there on these two surface treatments.
Well, that's
So
yeah. If you want to have lose about a month, put 3 designers in the same room with the same problem. Okay, so now we're looking at exterior glass, and these would be your the windows in your car and maybe the windscreen and stuff like that. So, Andy, why don't you kick it off and give us your name, title, and all the other stuff that goes along with it.
Sure, yeah. I'm Andy Woodfin. I'm the Commercial Technology Manager for our Automotive Glass Solutions Group. I've been here around 25 years, 10 plus years in the glass industry, do a lot of interfacing with customers, our direct customers, automakers on the technical and the commercial side.
I'm Tom Clary. I'm the Reliability Manager for the Auto Exteriors Group, and been with Corning for almost 14 years now, and prior to that worked about 15 years in the auto glazing industry prior to joining the team here.
Cool. Well, let's see what you got.
Yeah, so just to transition from the work you've done this morning with our interiors group, we have been in the exterior window space since about 2015 with Gorilla Glass primarily. So we take advantage of the same properties that we take advantage of for the interior displays to move into laminated windows on the exterior of the vehicle, really focusing on the thin but high strength attributes of Gorilla Glass. So that allows us to get into, like what you see here, laminated side lights, which are becoming a bigger and bigger deal in the auto industry for acoustics, performance, optics, stuff like that. We're also in a number of high-performance roofs in vehicles, especially large panoramic roofs with a lot more functionality integrated to them. We don't have an example of that here today. Probably our most visible example that we have in the industry is the Corning Gorilla Glass windshield that's on the Jeep Wranglers and the Gladiators. That's been out since about 2018. So we'll come back a little later and talk more about the side lights specifically. But I want to transition to the newest glass that we've introduced. So we've been, again, taking advantage of Gorilla since about 2015. We've got probably more than 1 million of these side lights on the road, and I can't go into how many of the Wrangler windshields, but there's a lot of those out there as well. But we just recently introduced what we call Fusion 5 glass, which is a different kind of glass compared to Gorilla, but it shares some of the similar attributes of improved strength, it enables weight reduction, and it can significantly improve the optics of, particularly on windshields. So Tom and the gang are going to walk you through the fundamental performance advantages of both Fusion 5, Gorilla, how we integrate those into exterior window laminates, and a real big focus on how we actually do the testing to validate the performance that we promise to the industry.
So this is soda lime. This is what's in your car today, float glass, right? And so at 90-degree angle incidence, it looks pretty good, right? So now as he starts to rotate it, you'll start to see these vertical lines appear, right? Those are those corrugations, that's that draw line distortion. And how this plays out in your vehicle is that if you're sitting in the driver's seat, for example, and if you're looking at an angle through your windshield, you'll see this distortion, right? I actually looked out in the parking lot this morning. There's some great examples out there of this, where you'll see these vertical lines, and maybe if we get a chance later, I'll get a chance to show some to you. Then you'll probably curse me forever, because once you see it, you'll never stop seeing it, okay? So in contrast to this, we have the fusion process. And I believe you saw some videos or something of this earlier today, where the molten glass goes into essentially a trough. We call it an isopipe. Glass overflows, comes down and fuses together. And what's important about that is the surfaces of the glass don't touch anything, right? And so you don't get any of this corrugation, you don't get any of those artifacts. You get a really high quality, display quality piece of glass. This is why this process is used for making the glass for your large screen TVs and things like that. And if you make a measurement of the distortion, it's overall about half of what float glass would do.
Actually, can we do this? You hold that one, and I'll hold this one.
Sure.
And
Hold them next to each other?
Yeah. And rotate them together.
That's
There you go.
yeah. That shows the difference. I mean, I love the clarity.
And so
And this matters both, like Tom said, once you see it, you can't unsee it. But as vehicles introduce more and more sensors behind the windshield into the ADAS systems, it's going to start to matter for the actual performance and operation of the vehicle.
Absolutely.
And the other element, right, is everybody has range anxiety for EVs and things, right? So one way to improve range is taking weight out, which we'll talk about that in a few minutes. But the other way is to reduce the drag, right? And so what we're seeing is modern windshield designs, the angle of installation, what we call the rake angle, the windshields are tilting further and further back, which means you're effectively looking through more and more glass. Right? And as you can see, as he rotates that, right, that angle is when that distortion really gets amplified. So we think, moving forward, because of the sensors and because of the design, you're really going to want the best quality optics possible for
Well, that the side by side really shows it. There's no question about that. So anyway, what do we got going on here then, Tom?
So now we're going to transition to some of the mechanical performance of the glasses and how we incorporate that. Our mission really is, at least personally, and I think company-wide, we want to make the world's most durable windshield, right? And so in order, and why do we want to do that? Why is it important, right? So right now, about 30% of all insurance claims are related to windshield breakage. Not glass claims, all insurance claims, right? So it's by far number one claim in insurance. Number two, right, the cost of replacements for the glass are skyrocketing, right? So it used to be you could replace your windshield for a couple $100. Now, because of all the sensor technology and so forth that's incorporated, you got to recalibrate all that. And so we're seeing replacement costs in the neighborhood of like $1,500, $2,000, right? So, and lastly, all those replacement windows, it's about 13 to 15 million windshields a year in the U.S. alone.
Million?
Yeah. Go to the landfill, right? So, or maybe get recycled in some way, but are scrap. So we pre-impacted a couple of samples so that we could get them over here on the hot plate. So these were both done at drop heights of 800 millimeters over there. So this is your windshield of today, and so it's got a little star fracture in the surface. This is our Fusion 5 glass. We've heated them up to about 65 degrees Celsius each, and we're going to thermal shock them with some ice water.
Oh, that'll be good.
And so I knew to do this because I actually, on my old Ford Explorer, I had a little star crack, was wetting my plants and decided to wash my car, hit it with a cold hose, and the fracture ripped right across it. So we'll let Tim do the honors here, where he can dump some water and you can see how the damage
Why don't
responds.
you walk over there and
So again, first, this is your regular soda lime windshield, and it's got a little star crack in it. And so you can see the willingness of that damage to propagate within that, right? That's because the shock applies stress and you already have damage present.
yeah, if you change that temperature just a smidge more, you'd have 3 pieces of glass instead of yeah.
Yep. Okay, and so now we'll do the second one. This is the Fusion 5 part. It's been impacted, got the little dimple in the surface. And so the stress experienced by the glass is directly related to the expansion coefficient. The expansion coefficient of this glass is about half of soda lime, so it just doesn't feel as much stress, right? And the damage stays stable.
Basically no damage.
Right.
Yeah.
So on the left is your regular soda lime glass. On the right is the Fusion 5 glass, equal thicknesses, equal size.
So you're getting almost 10 milligrams. That's or sorry, grams I should say, not milligrams. That's actually the car companies pay for reduction in weight. They're willing to. It depends on who you talk to, but somewhere around $6 a pound. So you have to switch grams to kilograms and whatever. But at the end of the day, that's a small piece of glass compared to a windshield, right. And getting up to, I don't know, what would you say? That would be 1/10 of the size of a windshield or something like that?
Not even, but so I can give you some numbers if you want.
But at the end of the day, you're going to get a kilogram. So just multiply that times 2. 6 times 2 is $12. I can pay $12 without even thinking about it to move into something else. That's per windshield. And if it has other characteristics, like it doesn't crack and whatnot, then you have to apply other factors, and you might get to if it's $1,200 to replace a standard windshield, should be a piece of cake to say, well, yeah, I would use it for marketing, advertising.
There's a lot of similarities here with the side windows. So this is an example of 2 different front side windows on a vehicle. A lot of similarities to what Tom was talking about for the windshields in terms of design, a trend towards EVs. So similar to the increase in rake angle that Tom was talking about, the installation angle for windshields, you've got a movement towards more laminated glass in side windows, especially on EVs. There's an appreciation for generally having more glass in the vehicle. There's the experience of the occupants as you remove the sound of the engine and that noise source, you start to become more aware of all the other noise sources out of the car. That's the biggest driver for laminating the side windows. If you ever look at a side window on a vehicle and it's labeled acoustic glass, what they've done is replaced a conventional monolith or a single piece of glass with a laminate. So it looks kind of like a windshield would.
Right, yeah.
And it's similar to construction that Tom showed for the incumbent windshields. It's typically like a 2 millimeter, 2.1 millimeter window glass, soda lime float glass on the outside and the inside, and again with a layer of that PVB in between. So there's 3 issues that come up with that the automakers and the customers are concerned about. One, as you go from that thick monolithic design, and that might be 3, 4, 5 millimeters of thick tempered soda lime glass, you replace that with 2 pieces of thinner glass with the PVB in between, your stiffness drops.
Yeah.
If you think about EVs that have frameless door designs, where there's no door frame around the top and the edges of the window, now I might be more inclined to open and close my window by grabbing the glass instead of the door. So stiffness starts to matter because I'm not going to want to have my high-price EV and feel that thing flexing. And also, as you go down the road or you get at highway speeds, air currents are going to pull that glass away from the vehicle. If the stiffness drops too much, you start to break the seal between the glass and the vehicle.
starts to whistle.
You'll hear it start to whistle. You'll get that humming. So stiffness matters. The appearance matters. If you can see the edge of this design. So this is a standard incumbent laminated side window. Again, similar construction to the windshield. You don't see the edge of the windshield. But if you have a frameless door in your vehicle, every time you get in and out of it, you're going to see this edge. And some people just think it looks kind of clunky. You can see the two pieces of glass with something in between. And you can feel it, again, if you grab it and hold the door. And then finally, there's the way you have to mount the window into the vehicle, how you actually mount the window to what we call the regulator mechanism that moves the window up and down. You don't have as much flexibility in the options of how you can attach the glass to the mechanical elements underneath with a laminated design. Typically, you can't put holes in the glass like you could with a tempered, monolithic, old-style window. So you're restricted in the number of options you've got for attaching it. So years ago, we've been doing this for years now with Gorilla Glass integrated as the inner ply of these laminated windows. And we address all three of those points, and we actually hit on a fourth one as well. So for stiffness, very similar to what we do with windshields, right? We get this asymmetric design that Tom talked about for the windshields, where we can keep the total thickness of the window the same as this one, but we put super thin, super strong Gorilla as the inner ply. That allows us to put a significantly thicker piece of standard window glass on the outside. There's the durability advantage we got for the windshields, not as much of an issue here, but for stiffness, your stiffness of a material goes by the cube of the thickness. So if I can put more material on one layer, this window is significantly stiffer than this one. Again, helps for that aerodynamic and the flexing issue, as well as the feel of opening and closing the door. And if you look at the edge of this one compared to this one, when I talk about that aesthetic issue, you get a much more streamlined look there. It's kind of dominated by that very thick outer ply. And in this case, this is 1.1 millimeter thick Gorilla, less than half the thickness of the standard soda lime that would be used there. So the appearance and the feel, again, of that one is better. And then one more thing that we can do, and I mentioned that flexibility and how you can attach the window to the vehicle.
I'm looking at that right now.
Yeah, you see this line that runs along the bottom here. What that is by making that outer ply super thick, we can now fully temper that outer ply. With a fully tempered piece of normal window glass, I can put holes in it. Since it's strong, thick, and tempered, I only put the Gorilla Glass where I need it. So we do this, what we call a belt line cut. We cut this right below the belt line where that seal is on the vehicle where the window goes up and down. So one, I only put the Gorilla Glass where I need it, and it can enable me to put holes in this glass. And you see one over here, which allows me to use any of the regulator attachment options that I might want to.
Mostly what we do is put a puck in here, a round thing. And, but this is expensive.
Yeah, these large, sometimes these can be aluminum. They're more expensive holders. You've got to have these put in jigs, mount them, have adhesives to adhere them to the window. So that may still be used on some designs with Gorilla. But again, you have the flexibility to choose whichever method you want.
Okay, so first off, Mike, thank you so much for the tour.
Yeah, absolutely.
This was brilliant. I mean, I had a good time. I learned a bunch of stuff. I'm truly enthusiastic about everything I've seen. What's in the future for Corning? I've seen all these wild things that I used to think I was up on technology, but I've seen all these wild things. What do you think? What do you think is your next step?
Yeah, so we walked you through a lot of things today. Primarily, we've been focusing on the inside of the vehicle and kind of those displays, making them be larger, enable higher resolution, manage the optics, giving them shape. So we've been working there, very big business for us. Second thing has been working on the outside of the vehicle. We're just starting to go kind of replace the standard soda lime with a lot of these technical glasses. And I think there's a lot of growth that's going to be available there for us. But beyond that, there's actually a bunch of other things we're working on we didn't spend a ton of time on. So first, head-up displays. So we got these head-up displays. We got these little small pictures that you see on that windshield. Those are moving to become much larger, kind of augmented reality, kind of push down the road, so that navigation systems that we see on our center stacks, how do we project those forward in the road, kind of keep our eyes on the road when we are driving the vehicle? So we're working on new processes, to be able to bend glass to an aspheric shape, which is kind of multi-bend, multi-radius as you go around that mirror, and pair that up with high-resolution displays and help create that augmented reality HUDs that are out there. So that's one thing we're working on. Second is, cars are becoming much more automated, right? So they can automatically brake, they can do cruise control, they can kind of do lane assist. All of those things are working on optics, free space optics that are typically behind the windshield or a sensor system that's somewhere else in the vehicle. And so since they all work with optics, we've got to go get from the transmitter out through some type of transparent media. So glasses are great for that. But I got to go protect those sensors. I got to go make sure the right optics wavelengths get through and then come on back so that the car can go react in the split second that it's going to have to do, because it's trying to replicate what we do so easily in our brains. So we're working on a bunch of those solutions as well, so that we can go help our OEM customers kind of navigate this new autonomous world that kind of all of us are driving right into.
Well, that was going to be one of my questions, was are you going to move into heads-up displays? So a heads-up display is good. Sometimes they work. Usually in bright sunlight they're useless, but you guys have got some techniques and technology that hopefully you can bring to the party. And the other thing I was wondering about is it'd be kind of a heads-up display, but I'd like to get rid of the rear view mirror and side mirrors, and could that be put into the windscreen as well?
Yeah, that is something that actually some OEMs are looking for. So if I can get rid of those side view mirrors, that's where actually a lot of noise comes into the vehicle.
Oh, absolutely.
Right, and that's hurting some of the aerodynamics of the vehicle. So yeah, high appetite to want to get rid of those or reduce them. Yeah. And displays can certainly help with that. We love that because it's just more glass, more displays inside that vehicle, and you saw how we can go solve a lot of those problems. And then I think the next step is, well, how do we get displays integrated into the laminate structures, that glazing that goes around the vehicle? And so we've been working with panel makers for decades now. And many of the displays, TVs that we kind of look through today, you can't see them, right? So you can't see through them. You're seeing a picture on them. But there's actually display panel companies working on what are called transparent displays. So you actually can see through them, but you also can put a display on them as well. And so how do we go integrate that into the laminate structure itself? So we're working with some panel makers to do that.
Is that a liquid crystal kind of a LCD?
So there are multiple different display types that can do it. OLED can do it. Micro LED can do it.
Yeah.
Both of those are both really good applications to be able to go get that transparent effect that you're looking for when the display is off. But then when the display is on, I've got some information that's being able to be displayed in here, and I can still see some things in that far off view as well that I might want to be able to see. And then what will be interesting is now we're going to take these displays, I'm going to add value to this laminate structure, and as Tom shared with you earlier, there's so many windows that break, 15 million a year right here in the United States. How do we stop them from breaking? And so now the value of the durability in the laminate becomes even more because we're putting so much more value into that window itself. So we think we can help our customers out with that.
Anyway, I just like to thank you again for giving me a wonderful tour and opening the kimono for us. I kind of know that you don't do this for that song. I don't do this for every guy I see. But anyways, I'm really happy that you let us in. This was really a good tour. I'm not kidding you. And
I appreciate you giving us some time here today.
Well, thank you.
Give us a little window of what is all like to be a glass company, and we hope you learned a lot of things
today. This was very eye-opening.
Excellent.
It was.
Excellent. Well, thank you for joining us.
And thank you for watching. Thank you.